All right, folks, thank you for coming back today. Welcome to day 2 of online welding theory. Hopefully, we're only in it for the 2 weeks and we can come back and get hands-on with things. So in preparation for getting hands-on with things, we're going to talk some hand tools today. I've got a PowerPoint. I'm going to share my screen. I'm going to kind of talk out the slides, let you know how some of the stuff works. It's a lot of welding related hand tools. Some are quite general. You'll see them, in a construction class, mechanics, all that stuff, but some are very welding specific and they have very specific jobs they do. And it's always good to know about them, especially when we're working in a welding environment, because we got some pretty slick little tools that can really help us out and save a lot of time and effort. So I'm going to bring the slideshow and start sharing my screen, and we will get this happening. So I'll share this here. Pop into here. Actually, let's go hand tools. Let's go size. Shrink that down. No, we don't want that way. We want it this way. Okay, pop it open with Google Slides, hit present. And this is the same way that you guys can view this. So if back on the last screen we hit pop out, it'll be here. Then you go to Google Slides and hit present. It'll show up nicely, just like this full screen. I'm going to close the door, just make sure it's nice and quiet. I don't have too much noise going on. So I will get that door closed up.
Yeah, people get weather like that 2 days a week. Absolutely, I don't care.
All right, so talk some hand tools, some general, some welding specific. All in all, a great thing to know. Basically, in the shop, whenever you're using hand tools, even if it's a wrench, a crescent wrench, a pair of pliers, we're gonna be wearing safety glasses. Too many things can go wrong in the shop. If we're pulling on things, prying on things, things can slip, accidents can happen. Heaven forbid it ever does. But safety glasses have saved me in more than one occasion from some serious potential damage to my eyeballs. We only have 2 of them. We need to protect them. So we're always using safety glasses. So we're talking some measuring tools, some really basic stuff here, guys. It is, we've seen tape measures. We've got lots in the class. I do find some students have a hard time measuring. So if that is the case, when we come back, I will run a very short measuring lesson just to get us all refreshed on how to use these devices. So we're going to operate in standard or imperial. There are 2 systems that we use for measuring, metric and imperial. We will operate in the imperial side, so that'll be in fractions of an inch. The metric side is going to be millimeters. So we're going to work with the standard, which is basically we use that because we've got some friends down south in the United States of America, about 335 million of them that use the standard system, and they have a lot of influence on what we do here in Canada, and they're also a big trade partner. So if we are working with them, selling them steel, they're selling us stuff, we'll often see things in both measurements. That's why a lot of tape measures come in metric and standard on the same tape. But we've got these steel rules we're going to use. We got a bunch in class here. We're hanging up on the tool board. We have on the right side of the screen, we have a standard tape measure and then a 30 meter or 100 foot or flex tape. So these things are nice because they're not made of steel. They're a little lighter. They can flex. You can wrap them around things. Say you're trying to figure out the circumference of a water tank. You can do that with those, and it'll be nice and accurate. They're also good for laying out larger things. I've got one of these. It's 100 meters, 300 feet. It's a giant one. We used to use that when we were laying out buildings. So lots of different things going on here. We got squares. There's about 15 different types of squares. Maybe that's a bit of an exaggeration, but there's a bunch of different types of squares. They all have their own purposes. These squares you see on the top of the screen here on the right side, those are generally for construction. It's carpenter square, framing square, and what it does, it gives a lot of, what do you call it, formulas on it for creating rafters and things like that. But they're great to have in a welding shop because when we're tacking legs onto a table or something like that, or putting up a frame, we want to make sure it's nice and square. So that's easy for reference. Tri-squares are on the bottom. These ones are kind of called machinist squares. They don't have any measurements on them. It's just you have a beam and a blade, and those are set at 90 degrees. I use these a lot in the fabrication shop and construction shop to check trueness of blades. If I'm working on the table saw, I will set one of these up alongside the blade to make sure that blade is completely vertical at 0 degrees before making a cut. Because if we're cutting at a couple degrees, that's going to give us a hard time when we're doing assembly. So we got other measuring and layout tools. Now these are pretty neat setups. This is a combination square setup. I've got one of these I will bring in to show you guys when we get back into the classroom. On the bottom left side of the screen, we have the beam with all 3 attachments on it at once. So generally you'll get a set of 3 different heads. We got the square head, we have the bevel head and the center head, and then we have a beam. This just is so they don't have to provide 3 beams, and you've got one tool that can do multiple things. So yeah, you got bevel, protractor, square head, and center head. Center head is great for finding the center of round objects. Could be, I mean, it has to be a solid object, can't be a steel pipe, but we're working with a 2-inch piece of solid stock and we want to find the exact center. The center head is a great tool for that. You can also use a combination square and a steel rule to find that, but that's a different method I'll show you in class. The bevel protractor, that is going to be for laying out angles. Say you have something very specific, you want to cut a piece at 37.5 degrees, or 2 pieces at 37.5 degrees for an included angle of 75 degrees. You can lay it out with that. You just set your degrees, put the edge on the top of your piece and scribe the line. I recommend using a scriber when working with one of these, because if we're using one of these tools, we're going to want to be accurate. So scribing a nice small line in is going to give you the best chance of accuracy. The scriber is basically, it looks like a dental pick. It's got a hardened tip on it. Some of them are tungsten. And what this does is scratches a very fine line in the mill scale or on the surface of steel, and it gives you a very thin, precise line. Whereas a soapstone, after they get dull, it's kind of like a big, dull crayon, right? You got a big, wide, fat line, and it's hard to be accurate with that. But all pretty cool tools, and I'll show you these when we get back in the class. We got some measuring and other measuring and layout tools. We have a level here. Once again, levels come in all different sizes. You can get them in 10 foot for great big doorways for completely accurate stuff. 4 foot, 2 foot, and torpedo levels are going to be the most common. These are standard size. I think we've got 3 of the 2 foot levels in class. They're going to look like the one on the top of the picture here. Torpedo levels, I don't carry too many of these in the class, but when I was working in industry, I had numerous of them. And in fact, in my toolbox at home, I probably have 4. So these are great for working on things like standing up beams, making sure things are plumb and level. To do this, you have to have 2 levels and hopefully magnetic ones. So they often have a magnetic strip on the bottom, so you can attach them to a beam and you don't have to have extra hands hold them in place, because we only have 2. And if we're welding or working, often we're supporting the beam with one hand, welding with the other, and then you'll just take your levels off afterwards. So pretty cool. Some of them have a 45-degree bubble in them as well for setting things at 45, but often you'll just find they have a horizontal and a vertical bubble. With these, pretty simple. When you look at the little bubbles and the vials in them, there's going to be 3 sections. There's going to be a center section, then there's going to be a black line on either side of it, and then a section on the left, a section on the right. We want that bubble in the middle, in between the 2 black lines. That is going to be how we know things are level. If we're to the left or to the right, then we need to adjust it to get that bubble in between those 2 black lines. Measuring and layout tools. These ones are neat. This is a pipe wraparound. This is a pretty cool tool. It's not completely welder specific, but it is a very, very handy tool if you're a fabricator or a pipe welder or fitter. So the way this works, it's a fabric style tape. It's long, probably 4 feet. They come in different widths. Some of them are longer for bigger pipe. I have numerous sizes of them, and I will bring one into class and show you guys, and we'll play around with it. What this does is it helps you lay out straight lines on pipe instead of making one mark and then just guessing a straight cut. What we do is we wrap this around the pipe, make sure it's nice and square, and then we wrap it 2 or 3 times, kind of like we see on the left side of the screen. And as long as the top edge of all of those wraps meets up and is level, then you should have a nice square line around your pipe. If not, we'll unwrap it, we'll adjust it, we'll rewrap it, because often you're working with larger pieces that are more expensive and you want accuracy the first time. Sometimes we don't have the option to grab another piece. So these are pretty nice. They're pretty cool tools, and I'll bring them in to show you guys. We got some marking tools. So we got soapstone. I kind of talked about this a little bit in class. It is basically chalk for steel. Soapstone is what is standard in the industry for marking steel. We also use things like temple sticks. Temple sticks are basically big crayons, oil-based. They mark steel. That's why you can see like heat numbers. When they make steel, they put heat numbers and stuff on it, and that's just, you know, what number that steel was assigned when it was being made, and that codes with a specific recipe, and then they'll be able to track all the steel in that shipment using the heat numbers, and they'll put it on there with a temple stick that doesn't wipe off. Soapstone will wipe off. So we can make measurements, we can wipe it off, we can correct it, but we can sharpen these up because they do get quite dull. So what I recommend is use a file to sharpen these up if you need accurate lines, but if you need really accurate lines, I do recommend going back to the scriber. Chalk lines, right side of the screen. It's helping us draw long lines, laying out big things. More on the construction side of things, but I've used these for marking out where walls are going to go on concrete pads. So you can mark where one end of the wall is going to go, mark where the far end of the wall is going to go, pull that tight between those 2 points, and you snap the line on the floor. It will shake chalk off, and it'll basically draw that line on the floor for you. This chalk can blow away. It can get rubbed off with boots and stuff like that. So if you want to save that line, a really cheap way of doing that is grabbing a can of aerosol hairspray from the dollar store, just some cheapo stuff. And then you spray that line with hairspray, and that hairspray is actually going to hold that line down to the floor a little better, and it's going to take more wear. So that is good. It's a great method if you need to keep your lines, say for half a day, a majority of a day, even a couple days. It will wear off, but it's going to be a lot better than having just that chalk sitting on the floor and hoping it stays there. Okay, we got some other marking tools. We got scribers. We kind of talked about those quickly. We can see them up on top of the screen there. Dividers. Dividers are great tools. They do multiple jobs. We can have a firm joint type or a spring joint type. Basically, firm joint uses resistance. You'll separate the points to a certain distance, and it generally doesn't move unless you drop it or bump it. The spring type, you use a spring and a little hand wheel. It will set that opening distance. You can measure between the 2 points on the bottom. They're very useful. So you may have seen these before. There is one reference I like to make to a movie, Pirates of the Caribbean. They use these types of tools for marking out and plotting paths of travel. So back in the days when they're sailing boats, they used to have stuff like this. And what they would do is they'd figure out how far they could travel a day on the map. And they would set that distance between the 2 trommel points, or the points on the bottom of the dividers. And what they would do is then they'd walk the dividers end over end over end along the sailing path. And however many times they had to move those dividers would tell them how many days that trip would roughly take. This is super useful for them because if they knew there was going to be a 10-day trip, they could put 10 days worth of food and water on that boat. Otherwise, it's just a guess, right? They might take way too much, or they might take way too little. But I like to use these in the classroom for laying things out at the exact same distance. If I'm going to be welding on a hook onto a beam, and I'm going to weld that hook every 4 inches, I'm just going to set these dividers at 4 inches. I'm going to flip them end over end and make a mark wherever that divider touches. And that's going to set my measurements out. It's a lot easier than taking a tape measure, measuring 4, 8, 12, 16, because we can make mistakes. When something like this is set, your chances of accuracy are much higher. So I like to use tools like that. Trommel points on the bottom, they help you draw out circles, scribed arcs and circles. Basically, you set your distance between the points. That would be your radius. And then you may need to put a little dimple in the piece of steel for the center point. And then you can swing that scribe around and it should scribe a circle out for you, or a radius, an arc, whatever you're working with. And this can also be done with soapstone to draw them out on a piece of plate. So basically a bigger version of a compass. Measuring layout tools, we got some marking tools. So I talked about putting a dimple in the plate. These are the tools that do it: center punches and prick punches. Center punches are going to be what you are going to use if you have to draw or drill a hole, or if you need to find the center of a circle or mark out where the center of a circle is. It's just a hardened steel point that we're going to place right on the center. Hold it in one hand, give it a whack with a hammer on the backside. It's going to create that dimple for you. So now you have the center of your circle and you're not going to lose that. From there, you can use trommel points and you can draw out that circle. So that's how it works. If we're going to be drilling, what I like to do is mark my places I'm going to drill with the center punch as well, because sometimes drill bits can do what's called skating, and they will flex just a little bit. They'll move off of the hole and they'll start drilling in a place where you don't want them to. So giving it a happy little home to start with the center punch is how we're going to be successful and accurate when drilling holes in the shop. Okay, tongue and groove pliers, talking clamping tools. We have all sorts of different pliers here. I've got a wall, probably got 5, 6 different types of pliers on those walls. They all do a different job and they're all useful in their own way. So tongue and groove pliers, they just basically kind of like water pump pliers. They adjust over a larger distance. They're nice. I don't really use them in here, but they will be common in pretty much any home toolbox. Slip joint pliers as well, that's B, and those are slightly adjustable and they will open up just a bit bigger to grab onto thicker items. We don't use stuff like that here. We use locking pliers in the classroom. Interlocking joint pliers and side cutting pliers, very similar. They both do some good jobs. So the tongue and groove and the interlocking joint pliers, fairly similar, but slightly different. The side cutting pliers, I call those ones linesman's pliers. You often see guys who work with rebar using pliers like this. They can twist up the wire and cut the wire with one tool. It's quite nice. We have side cutters, so we don't really need to use side cutting pliers like this. I got needle nose pliers. We know what those are for grabbing small little tiny things. Welding pliers are the ones that you're going to see most common in the classroom. This is one of the tools that we will have lots. Every booth should have a pair, and I probably have multiple pairs on the tool wall. Well, in fact, I know I have multiple pairs on the tool wall. Locking pliers down here. These are the ones that we have in the booths, more like the ones on the right. The ones in the middle are great for fabrication and assembly. I have plenty of those at home in my toolbox. These ones here, A, are for more sheet metal. They all serve their purpose. So sounds crazy, but these types of pliers here, pliers C and the locking pliers, are probably one of the more difficult tools in this classroom you will use. So when we come back, we're actually going to do a small lesson on how to use locking pliers. It sounds crazy, but it will be helpful for you, because if I don't do it, then I got a lot of people struggling with it, dropping their steel, potentially hurting their feet, losing it in the water buckets, things like that. So I'll show you how to use them. We'll play around with them and we'll have a good time. Clamping tools, all sorts of different clamps. A lot of them are shaped like C's. They all pretty much do the same job, and that is hold things. Bar clamps are for longer distances. You will see these more in the woodworking shop. So if we are assembling a tabletop and we have jointed and broken out pieces, we lay them all down, we glue the edges up, and then we tighten them up with the bar to form that tabletop and keep the joints tight while the glue dries. Spring clamps, Yeah, they're useful for certain things. I don't really keep them in the shop because they're plastic. They get melted, and then that's just a waste of money. I got a couple of steel spring clamps around that are pretty much the exact same thing, just in steel form. And parallel clamps on the bottom, also known as toolmaker clamps or carpenter's clamps, used to keep the joining surfaces flush to one another, but can use to clamp tapered objects as well. So they're adjustable. They can clamp straight objects. They can clamp tapered objects. I don't really use them in here. I don't do much machining, and I find these are more for machining style things. And maybe at a later date, we'll get into that. But for the moment, we don't need to know a whole lot about it. Vices on the table, the things everyone loves to play with. So these are vices. Some are swivel heads, some are fixed heads. Some have taken my fixed heads and turned them into swivel heads, and some have lost pieces for them. So I'm hoping to get those repaired by the time we get back. But long story short, that's an extra set of hands for you. Holds things, it's a great tool to work out of. If you're doing a bunch of hacksaw stuff like we will be doing in the hand tools unit and filing, these are going to be your best friends because they will hold the pieces for you while you perform the work on it. Some different styles for clamping round things. We got a machinist style vise on the right hand side, but basically the first two pictures, you'll see a lot of them in plumbing and gas fitting applications. So holding round objects, we have a chain style one, and then we've got a clamp style one, and then a machinist vise basically on the right side. And we're going to have those on our drill press. I use those quite a bit. So we got some cutting tools. These tools here are what you're going to be familiar with by the end of the hand tools project. Hacksaws. They work great. It's always good to know how to use them, even though in industry you don't use them that often. And well, I didn't anyways. But there is a time where you may not have power and you may have to cut something by hand. It's not the most fun, but at least you can do it and the job doesn't come to a stop. So we are going to be using these. Nice thing is with these hacksaws, they only cut one direction. So these blades, they don't have teeth that go both directions. They're going to be pointing in one direction only, and it's going to cut on the push stroke. So when you pull backwards, it basically cleans out the groove that you cut on the push stroke. And that way the saw blade does not get bound up inside of these. You might think the harder you push, the more you cut, but basically all that does is drive the teeth into the steel and gives you a harder time cutting. So nice and easy, a little bit of pressure, but not super hard, not super light, is going to be the key with this, and full long strokes. That's going to help you guys be successful. We'll go over all this when we get back to class, but figured I'd show you guys now. The files we see here, we got a bunch of different styles of files, come in different shapes as well. So we got a single cut, a double cut, a rasp, and a curved. The rasp is more for woodworking. It's got large teeth that rip out lots of material, and I use those for shaping items in the woodworking shop, not so much for steel. I don't think they would work very well at all. These files here, they're all shown without a handle on them. So what we see is right here, we have the section called a tang, and this tang needs to be covered with a handle. It doesn't have a handle, we're not going to use it in the shop. The handles are often interchangeable, they're threaded, and they will bite into here and keep this nice and secure. The reason we always use those handles is if we're using this without a handle and we're holding it back here, and for some reason this end comes into contact with something hard and stops abruptly, the point of this tang can end up in the palm of your hand. And that's something we're going to try and avoid in here. We don't want anybody getting hurt. So we got some files, different shapes of files. I mentioned they come in a bunch of different shapes. The most common ones we see in here are numbers 1 and number 3 and number 9. So just flat files is what they are. They are basically going to have the same cut on either side. Some you can have a single cut on one side, double on the other, basically a more rough cut and a smooth cut. The ones we have are pretty standard. We'll have either rough cuts or fine cuts, and they will be used for the hand tools project. I am going to get some curved ones like number 2, and that's going to help us shape the axe heads a little bit more. But they do come in a bunch of different shapes for a bunch of different tasks. Number 6, a round file can be used for cleaning out the inside of things. Also, you will see it, say if you were sharpening a chainsaw, you'll use a small round file to sharpen the teeth on a chainsaw. Triangle files, knife style files, they all have their purposes. So with files and chisels, got to be careful. They are super hardened steel. When you work with the steel though, and you make it hard, it has to give up a property to attain the hardness. So it's a trade-off. So what happens is standard steel, even though it seems hard, it's actually very soft. You can take a bar, you can bend it, you can do things like that. When you harden that steel and add extra things like carbon into it to get it nice and hard, you're going to lose what's called ductility. That is what gives the steel its ability to bend. These files will not bend, they will shatter. If you drop them on the floor, you can break the teeth. Sometimes the files even break in half. I've got plenty in the shop that have been broken because we need that hardness of the steel to cut regular steel. So we got to make it hard to cut regular steel, but we have a trade-off. We lose ductility, and that makes those files actually brittle. They can shatter, and the pieces that do come off them when they shatter are very, very sharp. So that's why it says here, do not use as a pry bar, hammer, or chisel. That's definitely a no-no. Also, we can use things like a file card if the teeth get clogged up. We can use a file card. It's a bunch of little steel fingers, needles on a brush, and they're going to clean out the files, and that's going to help maintain our files and help them cut nicely. Talking about chisels here. So we got a bunch of chisels in the shop as well, and we use those to remove steel spatter from our welds. I use it to remove slag from oxy-fuel and plasma cuts. They're just a great tool to have around. We do need to maintain them a little bit. Sometimes the edge gets dull, we'll sharpen that up. Sometimes the tops mushroom over a little bit from being struck with a hammer. The reason the tops mushroom is because we need to keep that steel soft if we're hitting it with a hardened surface like a hammer. When you hit a hard surface with a hard surface, bad things can happen. There's actually a Mythbusters episode on it. You can watch that on your own time, but maybe I'll show it in class even. But when we hit things with a hammer, the hammer is a hardened object. So we want to hit a softer object than the hammer. So that's why we keep the heads of chisels soft. What happens though is after hitting on them a whole bunch of times, they're going to mushroom out. We all kind of know what the shape of a mushroom is, how the top is rounded over. When that happens, small pieces can potentially fly off the head of the chisel. That's why safety glasses are very important. But what we do is we reground that chisel head until it's the original shape. That way there's no pieces that are going to potentially fly, and it's just part of chisel maintenance and safety. And if you're not confident in holding a chisel and hitting a chisel with a hammer, you can use some locking pliers to hold that chisel for you, get your hands right out of the way. That way, no matter how bad you are, well, maybe not how bad you are, like super bad, but if you were somewhat inaccurate while striking with a hammer, your hands would be in a safe place. We don't want to be smacking our fingers with a hammer. I did have a young lady in my last quarter who did damage her finger pretty good, and she ended up losing a fingernail. But this was after I gave her this safety talk and safety advice, and then she chose to make her own decision and end up hurting herself. So it's unfortunate, but it happens. My goal is to avoid all injuries in the shop with you guys. So chisel is going to look a lot like these shapes here we see on the left, or the right, sorry. Flat chisel, most common. Cape chisel, don't have any in here. Round nose chisel, don't have any. And diamond points, I've used one before, but I don't keep any in the shop. I keep basically a standard selection of flat chisels in here because that's all we really need to get into. Okay, metal snips. Cutting tools, tin snips, basically scissors for thin steel. The C and D are tin snips or aviation snips, as they're known. And there's actually 3 different styles of them, and they're going to come in different colors. So you got a yellow, a red, and a green. Basically, the color of the handle corresponds to which direction you're going to cut, to the left or to the right. These are set up to basically cut left and right cuts and circles on sheet metal and tin. A and B on the top are a little bit bigger. Hand shears used to cut metal 18 gauge and thinner. Yeah, that's pretty much it with those. On C and D, there should be one more, and it should have a yellow handle. That is a straight cut for tin snips or aviation snips, but I'll show you those in class. We don't use them often, but I do have them. Bolt cutters, we know what those are. That's what we use to pop those locks off lockers. Let's say you got your combination, or if you're storing contraband in there and we need into your locker. Hopefully that does not happen. Shouldn't anyways, because we don't have lockers this year. And side cutters on the bottom. Those are for cutting wire. We see those a lot in the shop. Welding pliers or MIG pliers incorporate side cutters into their design. So we often don't need to have more than one set of pliers or 2 pliers in the booth, 1 set of MIG pliers, and 1 set of locking pliers to hold and handle your steel with. Hand shears. So these are kind of like bigger scissors. It's like a paper cutter for steel is what it is. I've got one of these in the shop. It's blue and white. Some of you may have played with it a little bit, and I will cut steel up to 1/8 of an inch thick using this shear. It says you can use up to 1/4. I would not want to on the one we have. It is not quite as large as some of these. But you can use it. Eventually you can cut circles. You can basically, if you're cutting sheet metal, you can make a circle by cutting a whole bunch of flat sections. So it'd be like some sort of, I don't know, 50-sided circle instead of, just a round circle. Yeah, but they're neat tools. We'll play around with it a little bit, especially when it comes to gas metal arc welding, because I will have you process your own steel that you are cutting. Hammers. Long story short, we use them to smack things. They come in a whole bunch of different styles and probably one of the earliest tools man ever invented. Besides a knife and a hammer, I mean, hammers look different back then. They were probably just smashing things with rocks, but the idea was there. We use ball peen hammers in the classroom, and ball peens are going to be the one on the top right of the screen. It's going to have a rounded end and on one end, and then a face on the other. The peening end is good. You can use it for multiple things. Some people use it for removing stress from welds. That means you have to beat the weld pretty much senseless, but it helps take stress out of it. I use it to put a nice hammered effect on some steel. If you're making something decorative, it looks pretty good. Generally, handles are made of wood. I have replaced a bunch in my shop with handles that are made of a composite material, and then the head is glued in place. If for some reason the handle is broken, head is loose, something does not seem right with it, we're not using it. Just let me know. I will get it replaced. I'll go buy some new ones. I'll put a new handle in. I don't care. Safety's number one, and we don't want one of those heads flying across the shop when we are using it. In a wooden handled hammer though, that head is going to be secured with a steel wedge. What happens is we drive the wedge into the wood of the handle. It pushes the wood out to the sides into the basically head of the ball peen hammer, and it's going to hold it in place via a wedge effect. The hole in the top of the ball peen hammer is called an eye. So we fit the handle into the eye, and then we drive the wedge in, basically securing the head to the handle. We got sledgehammers. We got one in the shop. We use it to move things. I call it my coercion tool or convincing tool. Sometimes we need to get a little bit aggressive with things, let's say. And so I've got that tool for that, but I try not to use it because there are smarter ways of going about things besides just getting a bigger hammer. We have chipping hammers in the shop as well. Every booth is going to have one of these. This is for chipping the slag off your welds. Some welding processes produce slag, flux cord arc welding, shielded metal arc welding. Those are going to produce slag on the welds, and we need to remove that before we make the next pass. That is where the chipping hammer comes into play. You chip the weld off, you use your wire brush that's in your booth, you brush it nice, make sure it's nice and clean before you start your next welding pass. Otherwise, you got a risk of trapping stuff, or like that slag, we can trap that in the weld. That would be basically a discontinuity or a weld defect, and on a job like I used to do, that would be an instant failure of the weld, and potentially my job. So we want to make sure welds are clean before we move on, because preparation is key. Safe use of hammers. Basically, hold the hammer properly, keep your fingers away from it, make sure that the handle's in good shape and the head is secure. And that is it. I do a lot of checks on all my tools in here. In fact, I just replaced 4 ball peen hammers because I didn't like them. And now I've got some nice new safe ones in here for you guys. Screwdrivers, we know what these are. We've used them. The only thing we basically need to know is that even though we see the Robertson there and it's square, or the Phillips with the cross, they come in different sizes 1, 2, and 3. We need to fit the correct screwdriver to the correct screw size for it to work properly. Otherwise, it's just going to strip, and it's going to be a pain in the butt to remove. So yeah, if we come across that in the shop, I'll show you guys an example and we'll work together on that. Punches, these are great. I use them for driving pins out of things. We got pin punches like on the top right of the screen. Those are great. I just did some work at my old house before I sold it. I wanted to take some doors off, do some painting. I used one of those pin punches to knock the pins out of the door hinge, so I didn't have to unscrew the door hinge. Then you place the door back in, you tap the pin back into place, and life is great. Drift punches, I used to use those all the time for various things. When I was at Lafarge, I did a lot of mechanical work, and they have their time and place. So I'll show you guys those when we get back in the shop. Pinch bars, pry bars, don't really use them that much. Oh, sorry. But they do have their place. If we're working a pile of steel, you need to move, separate some stuff, lever some things around. They're great for that. We got some wrenches, lots of wrenches going on in my shop. We got combination wrenches. That is a box end and an open end. We've got things like our socket sets, lots of stuff like that. You guys are pretty familiar with it. We don't use it too much, but if we do come across it, I will show you guys that. We got some Allen keys. We got Allen keys are actually pretty common on welding things. Things like our electrode holders, they are assembled using Allen keys. I will take one apart. I'll show you how they work, how to basically check your electrode holder, or how to repair it if it is not working, or say the cable falls out. Generally, I do all repairs in the shop, but I just like to make you guys aware of how to do it. Pipe wrenches, chain vices, strap wrenches, they're all for gripping onto round objects. If you're working with something you want to keep a nice finish on, you don't want to use a pipe wrench. They have hardened jaws, they'll bite in and mar up your surface. So you might want to use something like a strap wrench on the right side of the screen. It is made of nylon. If you keep it clean, it should not scar up your round surface too bad. If it's very important that this stuff stays nice, there are different ways of and different tools we can use to keep that nice. But don't generally use them that often. We don't need to in the shop. Wire brushes, got lots of them. Every booth has one. I got a bunch extra. They're great for brushing off our welds, keeping things clean. You know, even if you have a barbecue that needs cleaning, these brushes work great for that. I wouldn't use a welding one on a barbecue though, obviously for, you know, health reasons. But yeah, they're just great. That's what we use to clean up our welds in the shop. And that is that for that slideshow. So I'm gonna stop sharing the screen. This slideshow is going to be available to you, and it will be in our class unit, the FAB 1010 unit. And with this, this is what we're going over today. I'm going to have a quiz on this for you for tomorrow, but this is open and available for your viewing and review. So it will be located in D2L. I'm actually going to share my screen again, show you where it's located. And let's get that happening. So we'll share the screen here. We'll select this one. We're going to escape out of this if I can. Having some trouble with this. There it is. Okay, we're out of there. So what we're going to do is we're going to pop back in the hand tools here. And what we can see is it's our fabrication 1010 unit. So we got fabrication orientation, hierarchy of controls, hand tools, brand new. I popped that in there for you guys. So you can see this PowerPoint right here. We're going to have a matching assignment coming up in a day or so, and then the hand tools test. So this is your review for that. That's all for this class, guys. Make sure your name is in the chat for attendance purposes, but that is it. We will have a quiz, yes, but we're not doing it today. We're going to do that in a couple days here. So I'm just going to give you a little bit at a time. I don't want to overload you guys because you're spending a lot of time online with this class and other classes. So that is all for today, folks. No homework, but review that slideshow. Okay. Thank you much. It's lunchtime. You guys go get yourself some lunch. Have yourself a great day. If you have any questions, send them to me right now. I'm going to stop this recording.